Wooden organ pipes, such as godecks and block flutes, are usually fitted with wooden pipe feet. We make these wooden pipe feet in 6 different sizes. Although the 6 sizes differ in most of their dimensions, there are 2 dimensions that are identical in all of the feet. Here seen in cross section, the length of the tapered portion of each foot is 20 millimeters, and the length of the small central hole is 4 millimeters. These wooden pipe feet are made from standard size birch dowel rods. The process for going from dowel to the finished foot may be broken down into 6 steps. First, a bandsaw is used to cut a slot around the dowel to form what will become the shoulder of the tenon section of the foot. Second, the slotted piece of dowel is cut to the overall length of the foot. Third, the tenon of the foot is cut on a lathe with a tenon cutter. Fourth, a large central hole is drilled partway through the foot on the lathe. Fifth, a small central hole is drilled on the lathe. Sixth, the taper of the foot is produced on the disc sander. The steps just illustrated can be broken down into 3 stages: operations on the bandsaw, on the metal lathe, and on the disc sander. First, we'll discuss the operations on the bandsaw. We use a bandsaw jig, which is a flat board with a wooden crosspiece fastened at 90 degrees. This section is beveled, the purpose of which we'll explain shortly. The jig has a guard mounted to help keep fingers away from the saw blade. The left side of the jig rides against the rip fence of the bandsaw, and the jig forms a sled on which the dowel is carried into the bandsaw blade. Let's now set up the bandsaw and jig to determine the various dimensions of the pipe feet. A finished pipe foot of the desired size provides a useful gauge for setting the rip fence to the overall length of the pipe foot, measured to the inside edge of the blade. Next, we position the jig on the bandsaw so that it rides against the rip fence. The safety guard has been removed temporarily to show details more clearly. This is the spacer for the tenon shoulder slot, which sits on the left side of the jig and also rides against the rip fence. The spacer is made with a thickness equal to 20 millimeters plus the width of the bandsaw kerf. With the blade illustrated, the kerf is 1 millimeter, meaning that the spacer is 21 millimeters thick. This same spacer is used in making all 6 sizes of pipe feet. The dowel sits up against the spacer so that the saw blade can cut a circumferential slot for what will be the tenon shoulder. Next, we determine the depth of the slot for the tenon shoulder. A stop block is clamped to the far end of the bandsaw table. We place a removable index stop so that it limits the travel of the jig and dowel at a position that determines the depth of the slot. A guide block glued to the bottom of the index stop rides along the right edge of the bandsaw table and helps ensure that the index stop is always in the same lateral position. A screw permits fine adjustment of the depth. With the bandsaw motor off, place the 21 millimeter thickness spacer in position, and then place the dowel on the jig and slide the jig so that the dowel just touches the stationary blade. The stop block is positioned so that the index stop rests firmly between the end of the jig and the stop block. This position would correspond to a dowel slot with a depth of 0. At this point, turning the screw in or out will change the depth of the slot by a corresponding amount. The screw shown here is a number 12 round head wood screw which has slightly over 10 threads per inch. Each revolution of the screw changes the depth by about 3/32 of an inch. For example, we see here pipe foot size number 3, which starts as a 7/8 inch diameter dowel. The diameter of the tenon in the finished foot is 5/8 inches. This means that a slot cut around the dowel to produce the shoulder of the tenon needs to be 1/8 inch deep to match the diameter of the tenon. This 1/8 inch depth can be achieved by turning the adjusting screw in 1/8 of an inch, which means turning the screw about 1 1/3 turns. The actual depth of the slot or the diameter of the tenon shoulder can be verified by trial cuts on dowel samples and adjustments of the screw as necessary. We proceed now with the bandsaw motor on to place the adjusted index stop against the jig, to place the thickness spacer on the jig and against the fence, to place a section of dowel on the jig, to slide the jig to push the dowel into the bandsaw blade, and to rotate the dowel against the blade to cut the slot. Let's now check the depth of the slot we've just cut. The jaws on most calipers are too thick to fit into the 1 millimeter kerf of the slot. One way to solve this is to make a simple caliper from a thin card, such as the plain 3x5 index card shown here. We illustrate this with a number 3 pipe foot, which has a tenon diameter of 5/8 inches. We take the 3x5 card and cut a 5/8 inch slot. A finished foot can be used to check the fit. This caliper card is then used to check whether the diameter of the shoulder slot is indeed 5/8 inches. If the shoulder diameter is off, then the index stop screw is readjusted appropriately, and we repeat the process of cutting a sample slot and rechecking. Now that the depth of the tenon shoulder slot has been properly adjusted, we can go ahead with the actual production of the bandsaw stage of the pipe foot. We start with the bandsaw jig in place against the rip fence. Recall that there is a bevel or slope on this part of the jig. We place the adjusted index stop against the jig, place the thickness spacer on the jig and against the fence, place the dowel on the jig against the thickness spacer, slide the jig to push the dowel into the bandsaw blade, and rotate the dowel against the blade to cut the slot. Pull the jig back and remove the index stop and thickness spacer. Slide the dowel directly against the rip fence, and then cut the slotted piece off to the final length of the pipe foot. Note how the bevel on this part serves as a ramp to help the cut-off piece of dowel roll out of the way. And now the foot is ready for the next stage of the process on the lathe. The next stage of foot production consists of 3 steps on the metal lathe. These are: 1. Cut the tenon. 2. Drill the large central hole. And 3. Drill the small central hole. All 3 steps are done with 1 chucking of the foot in the lathe. The foot, after the bandsaw procedures and ready for the lathe, shows here the slot for the tenon shoulder and a segment which is 20 millimeters long for all the different foot sizes and which will eventually form the tapered segment of the foot. The other end, usually less than 20 millimeters long, will be the tenon segment. Start by inserting the taper end of the dowel piece in the three-jawed chuck with the tenon end sticking out so that the shoulder slot clears the jaws by about 1/4 inch. Centering should be close but need not be exact. Be sure the jaws are tight enough so that the piece won't slide or move under pressure. The jaws will leave small indentations in the dowel, but these will be removed later when the taper is produced, so need not be a concern. Incidentally, if possible, 3 separate tailstock chucks should be used for the 3 different steps on the lathe for efficiency. Insert the tenon cutter in its chuck in the tailstock. Slide the tailstock so that the tenon cutter is in contact with the dowel piece and tighten the tailstock to the lathe bed. Now start the lathe and advance the tenon cutter with a tailstock screw to cut the tenon, the stop point being the pre-cut tenon shoulder. Now that the tenon has been cut, the next step is to drill the large central hole in the foot. Insert the large drill in its chuck in the tailstock. Drilling the large central hole is the only step in the lathe operations that requires measurement. Let's look at the cross section of the foot and recall that the small central hole is 4 millimeters long in each of the foot sizes. The overall length of the foot minus the depth of the large hole equals 4 millimeters, the length of the small hole. Thus, drilling the large hole to the correct depth is what determines the 4 millimeter length of the small hole. For example, a number 3 foot has an overall length of 36 millimeters. 36 minus 4 equals 32, which would be the required depth of the large hole. The lathe gauges are calibrated in inches, so we need to convert 32 millimeters to 1.260 inches. We use the linear gauge on the tailstock spindle combined with the rotary dial gauge to determine the travel of the drill. The tailstock ejects the chuck when the spindle is retracted to less than 2/10 of an inch, so the spindle must be extended at least this far to accept the chuck. For this reason, we cannot start with the gauge at 0. My method of choice is to set the gauge at an initial reading of exactly 0.5 inches. With the lathe off, slide the tailstock so that the tip of the large drill makes firm contact with the tenon end. Tighten the tailstock to the bed and turn the lathe on. Now advance the drill with the tailstock crank to the desired final gauge reading. And how do we know what the final gauge reading should be? Again, using the number 3 foot as an example, recall that the depth of the large hole should be the overall length minus 4 millimeters. For the number 3 foot, the calculated depth would be 32 millimeters or 1.260 inches. Since the tailstock gauge was initially set at 0.5 inches, the final reading should be 1.260 plus 0.5 or 1.760 inches. To summarize drilling the large hole, First, set the tailstock gauge to 0.5 inches. Slide the tailstock so that the drill tip contacts the tenon end. Tighten the tailstock to the lathe bed. Bore the hole by advancing the drill until, as an example of the number 3 foot, the gauge reads 1.760 inches. The final step on the lathe is drilling the small hole. Replace the large drill with the small drill. Slide the tailstock so that the small drill makes firm contact with the end of the large hole. Tighten the tailstock to the bed and advance the drill until it penetrates the far end of the foot. No measurement is necessary. Now we can remove the foot from the lathe and measure the actual length of the small hole. Recall that this is the dimension we're measuring, and one which should be 4 millimeters. Take a twist drill with a diameter 1/10 or 2/10 of a millimeter larger than the size of the small hole. The back end of this drill should fit snugly just at the inner mouth of the small hole and provide a reference point for a depth gauge. For a depth gauge, use a drill with a diameter smaller than the size of the small hole. A straight wire would do just as well as a drill. Mark 4 millimeters at the back end with permanent marker or tape and insert into the small hole until it contacts the end of the larger drill. Here we take a drill with a diameter 1/10 or 2/10 of a millimeter larger than the size of the small hole and insert it to bottom out snugly at the inner mouth of the small hole. This is a drill with a diameter smaller than the size of the small hole, and 4 millimeters has been marked off the back end with tape. This serves as our depth gauge. If the length of the small hole deviates from 4 millimeters, the depth of the large hole can be adjusted accordingly. We now come to the final stage of making pipe feet, producing the taper or conical end of the foot. Instead of turning the foot on the lathe, the taper can be produced much more quickly by using the disc sander. The partially finished foot, which has had the tenon cut and the large and small central holes drilled, is rotated against the sanding disc at an angle. The foot is mounted on a steel mandrel, and a jig mounted on the sander table guides the mandrel and foot up to the disc at the correct angle. Let's look at how this is set up. This is the jig mounted on the sander table and with the mandrel resting in this V-shaped guide, and here seen in top view. Here the guide is shown from another angle. The large central holes in each of the 6-foot sizes have different diameters, so we require 6 different mandrels, one for each foot size. The tip of the mandrel needs to fit securely into the large central hole with no wobble or slippage, but not so tight that the foot cannot be readily mounted and removed. In addition, the mandrel and its tip must be perfectly straight and concentric. Any bend or off-centeredness will make the tapered section out of round, meaning that the tapered section will not fit properly in the toe board. The taper of the foot has an angle of 2.7 degrees measured from the center line. This is true for all 6-foot sizes. The mandrel guide is mounted so that it sits at an angle of 2.7 degrees to the face of the sanding disc. The mandrel and foot are advanced while rotating the foot up to a point determined by an adjustable end stop, as we see here, and again shown here from the top. The end stop pivots and can be adjusted by a bolt that can be screwed in and out to make fine adjustments, and by a screw that is tightened to lock the stop in position. The jig is outfitted with a mounting strip, which is used to secure the jig to the sander table with clamps. The jig is connected to the mounting strip by an adjustable bolt on each side. When the mounting strip is clamped to the sander, adjusting the two bolts on the sides moves the jig in or out from the sanding disc, and by adjusting the two bolts separately allows us to adjust the angle of the jig relative to the sanding disc. To set up the jig, we proceed as follows. Start with the sander off and with the jig resting on the sander table, but not clamped to the table yet. Pivot the end stop to its mid position so that it can later be adjusted in either direction if necessary and lock in place. Take a finished pipe foot of the size to be produced and insert it on the appropriate mandrel. Position it in the guide and advance it so the foot is up against the end stop. Now maneuver the jig so the tapered portion of the foot makes firm, flat contact with the sanding disc. At the same time, make sure that the jig is exactly parallel to the face of the sanding disc. Clamp the jig to the sander table, taking care not to disturb the position of the jig. At this point, we are ready to produce a sample foot to see how close we are to the desired dimension. Mount the dowel piece on the mandrel and turn the sander on. Position the dowel piece back on the mandrel guide and carefully slide it forward. The clearance between the dowel piece and the sanding disc is very close, and care is needed that the disc doesn't grab the wood while you position it. Advance the mandrel while rotating the mandrel counterclockwise, that is, against the direction of rotation of the sanding disc. Make at least one or two complete rotations after the foot hits the end stop to ensure a smooth final surface. Back the mandrel off, and we are ready to measure the result. We measure the taper primarily by using a reference board with conical holes made by the same tapered reamers used in making the toe board. In addition, the diameter of the large end is one of the listed dimensions of the foot, and we can check this with calipers. If the fit and the dimensions call for an adjustment, we can change both the final diameter of the foot and the angle of the taper by adjusting the two bolts that connect the jig and the mounting strip. We can also make a very fine change in the diameter of the foot by adjusting the position of the end stop. If our measurements are satisfactory, then all things are set to go ahead with producing the tapers for that size foot in quantity.